this is maybe the last time that they're going to let me use this picture. I've gotten a lot of pings from people telling me to get a new headshot. So just heads up that this might be the last time that we see this. There is a story behind it. I generally don't dress up like a reindeer. I think this was the only time, actually. Yeah, anyways, we can talk about that later if anyone has any questions. So today I'm going to be talking about Avalanche 9000, more on the technical deep dive side. So might have less fancy graphics than the keynote that we just watched, but should go over kind of all of the ACPs that I feel are like really important as part of the upgrade. So quick list of the top kind of 5 that I think people are primarily interested in. So the one that Gun had already kind of mentioned during his keynote was ACP77, Reinventing Subnets. Really, there are 2 goals as part of ACP77 that were kind of the origin story of why we wanted to do ACP77. The first one being to significantly reduce the capital requirements to launch subnets, now branded as layer 1s. I think Gun had a slide where it was 2,000 Avox lockup per validator as a minimum, and that comes out to tens of thousands of dollars. We're targeting a significantly lower amount, so somewhere in the ballpark of like an Avox per month, or maybe even less, depending on what the fees come out as. So we should be significantly reducing the barriers to entry as far as launching layer 1s with ACP77. We're also going to be significantly improving the flexibility of these layer 1s. So some people might not actually know this, but there are already permissionless subnets that are supported in Avalanche. They're called BAMF elastic subnets. The reason people might not know too much about them is I believe that there are exactly 0 on mainnet right now. So we'll go over a little bit later as to why maybe those didn't work as well as we had expected. But yeah, the next ACP that we want to kind of talk about, or that we will talk about, is ACP 103, which is dynamic fees on the P chain. This is, again, going to be focusing on reducing the costs of transactions. So, again, reducing the barriers to entry for people to participate on the P chain. ACP 125, reducing fees on the C chain. This is, less so a like theoretical improvement on the C chain, but more of a price fixing, like a price miscalculation fix that we're doing, and we'll go over exactly how that works. And then the 2 remaining ACPs talk about a lot of warp verification, which is very much at the heart of ACP 77. So if we want a quick TLDR, we're basically trying to lower fees as much as possible across all of our chains here, and double down on warp messaging for basically its flexibility and also improving its UX. So first things first, let's dive into ACP 77. So I kind of have over onto the right side here what the focus is for what we're talking about right now. So this is specifically focusing on the reduction of the capital requirements. It's kind of cut off, but I think you guys get the gist. So as of right now, the primary network is a collection of all of the validators of the Avalanche network. And subnets are sub-networks contained inside of the primary network. And this means that in order to be a subnet validator, you have to put up the primary network requirements of 2,000 Avox, which, as we had talked about already, is very price prohibitive for a number of people. The network architecture is very fundamentally changing with L1s because they are no longer actually sub-networks of the primary network. They are still connected, so they're still living on the P chain as a registry, and that's important for warp messaging and interaction. But the actual validators are not necessarily going to be overlapping anymore. So this changes a lot of, say, the P2P network and a lot of some optimizations with warp messaging that kind of needs to be handled at the underlying level. But what really matters here is that, again, this removes the 2,000 Avox stake requirement. It does introduce a different mechanism that has to be preventing people from, say, DOSing the network with too many validators, because, again, this does change very fundamentally the P2P layer. So rather than having that 2,000 cap requirement, there is a dynamic fee that essentially charges a running bid for whatever the resources requested are. And again, we'll talk a little bit about how the fee mechanism works later. So here is kind of an example or a description of the existing Banff permissionless subnets. So currently we start off by issuing a transformation from a permissioned subnet to a permissionless subnet using a transform subnet TX. Here are some interesting design decisions that came into permissionless subnets with Banff. The staked asset had to be an asset created on the X chain. So that means that any ERC20s that are spun up on the C chain, those wouldn't actually work necessarily as a staked asset. The transform subnet TX allocated all of the staking rewards pool, and the staking rewards formula had to follow basically the same minting curve as the Avox token. So if we asked people, hey, what are the things that you liked about Banff permissionless subnets and what are the things that you didn't like? This was kind of the breakdown. So they were happy that they were able to convert the subnet into a proof of stake subnet, but they didn't really like anything else. So the idea with L1s is to, rather than kind of pushing for any specific staking mechanism or any rewards curve or anything like that, what we wanted to do is make it fully general. So what we ended up doing was we said any changes to a new L1's validator set are going to be performed by a warp message from a chain that is specified in the convert subnet TX. This basically allows any arbitrary staking contract to determine all of the interesting things like staking rewards, subnet eviction, validator weight changes, things like that. So it fully generalizes as much as you can how you would actually define the validator set for your L1s. So I talked a little bit about this kind of fee for validators in ACP77, and it really is just an extension of the fee mechanism that we use for in ACP 103. So going over how ACP 103 works is kind of a prereq. So at the end of the day, ACP 103 is just a basic supply and demand model. So if you took any intro to economics courses, we might be used to some of this stuff, but we have, say, our price and our units graph, where we have some supply curve and we have some demand curve. And wherever the kind of curves intersect is when your market is going to have stabilized for wherever your price and unit amount should match. In blockchain, it's a little interesting because the supply curve is generally fixed based off of the hardware requirements for validators. So you can't really scale up and just say yeah, we're going to have infinite TPS. What you kind of need to do is say, here's the hardware that validators are going to be running, and that's how much we can process. And then the demand curve is going to be some weird curve that is constantly changing over time. But what you want to do is you want to set your price such that you are hitting that ideal kind of point. Currently on the P chain, we don't do this. we basically just set a fixed price of a Vox that is higher than the required price, because that avoids any DOS possibilities, and it was very simple in the early days. But what we want to do with ACP 103 is actually calculate where this supply and demand curve interact. So this will very, this will very explicitly reduce the fee, because right now we are very much running below where we want to target our usage on the P chain. And similarly, this extends to the C chain. So the C chain has a very similar mechanism. And the way that the mechanism actually works is by multiplying the prior price based off of how much you're actually using. So if we start with like a guess of this price and this gas usage, we'll see that we're actually way over target. So we're using way more gas than we actually want to. So we will update for the next block to kind of have a higher gas price to get closer to this target. Eventually, we'll keep performing this, and we'll hit this kind of like ideal point where we're saying, okay, we're like happy here. Of course, the curve can look very weird sometimes, and it can change. So in order for this mechanism to work, we actually have to set a minimum price. So this minimum price is basically arbitrarily selected. And on the C chain currently, that price is 25 nanoavox. Now, if anyone has actually used the C chain, you'll know that the price for gas is probably 25 nanoavox, which means that this minimum price is set way too high. Essentially, this dynamic fee algorithm isn't even kicking in on the C chain typically, and it only kicks in during unusually high periods of demand. So the ACP 103 is basically lowering this minimum price. So it is not necessarily going to reduce the fee spikes, but it will almost certainly reduce the kind of average fee that most people hit during normal operations. So this is very much the same mechanism that is being used in on the P chain after this upgrade. And similarly, this same price discovery mechanism is going to be used for ACP77 validators. So what that means is we'll be setting some target for subnet-only validators, or layer 1 validators. And if the number of validators exceeds that target, then the rent price or recurring charge for those validators will increase until we hit that number of target active validators. So I think the current number that's being thrown around is around 10,000 active layer 1 validators to start, with a cap of 20,000. And of course, these numbers will kind of change as the network evolves, and typically these numbers are set as kind of conservative to initially run the network, and then we kind of increase as we become more confident. A lot of this work for ACP77 hinges on the ability to efficiently send warp messages between chains, specifically between, say, a new L1 and the P chain. So a little bit of background on warp messaging. You basically have a source subnet, or L1, and a destination L1. And you have this relayer mechanism that is trying to basically send these messages across these different L1s. Currently, all of these warp messages are fairly bespoke to the actual layer 1. So this ACP 118 is going to be standardizing the interface for how these warp messages are actually generated. So that a generic relayer can basically be implemented that allows for aggregating across any L1 that implements this standard. This is one of the things that we've kind of been hitting as we've been implementing ACP77 and also kind of like dogfooding it over time, is that we've kind of hit these pain points of, wow, this is kind of really annoying. Like, we can feel that, people are going to be running into this and having hard times using it themselves. And so this is one of those kind of like ACPs that come out as a, hey, like this is a nice DevX improvement. Similarly, we have another ACP that'll be changing how warp messages are verified. So a bit of background. The P chain works by basically setting all of your validator sets. So at any point on the blockchain, you have a specific validator set for any layer 1. Other layer 1s will explicitly reference the P chain in order to have a consistent validator set. And this is used for block production on that subnet. So what ends up happening is in order to know exactly which validators can generate blocks, we have essentially a reference to the parent's committed validator set, and that provides a deterministic mechanism for producing blocks. The annoying thing here that you can see is that this L1 block still uses the pchain height 0 because it needs to reference the parent's pchain height to get that deterministic block at that height, block height at that height. But in order for warp verification, we actually really don't need that. But pre-Etna, we still use that for consistency. And during the kind of playing around and developing of ACP77, we found that this was, again, really kind of clumsy and difficult to interact with. So we suggested changing this behavior in with the ACP151 to basically update the warp verification to use the height that was included within its own block. That's fine for warp verification because warp verification is still going to be deterministic based off of that pchain height, but it is possible for different blocks at that same height to reference different pchain heights, and that's fine because you're not trying to use that to determine who can propose the block at that height. So at the end of the day, that's really the main focus point of all of this, where ACP77 is trying to build out all of the tooling and flexibility required for layer 1 blockchains to deploy. And all of these kind of improvements are really feeding back into ACP77. So we actually have a DevNet live right now that I think we've been trying to push people to use. So all of these upgrades, with the exception of 151, I believe is live on the Etna DevNet. So anyone here can basically pull that up, and it sends you to a GitHub repo that has a pretty thorough tutorial on how to interact with all of these new ACPs. And I can tell you right now that there are 2 bugs in the DevNet. And as of this point, no one has hit them. So if anyone here can find one of those 2 bugs and crash the DevNet, I will give you not a huge amount of a box, but some amount, probably like 5 or 10 a box. I'm not balling out here, but like I'll give you a little bug bounty. So you say 5,000? No. How about I'll commit to 10 a box if you can crash the DevNet today. 5 if you can crash it over the next couple of days. I will be ecstatic if someone can crash it, by the way. So I sincerely do mean that because I love paging our infra team. Anyways, are there any questions? I know I went over a lot of stuff. There's a lot of things as part of Avalanche9000, so I wanted to run through stuff, but I think we have a couple of minutes for questions, if there are any. Yeah, go ahead. I'll just repeat your question. Yeah.
Can you talk a bit about the validator management? The original documents
Yeah, let me pull this up. So when a convert subnet TX, TBD on the naming, because there's a big push to rebrand everything to L1s right now. When that is issued, that includes kind of the genesis validators of your subnet, along with who has the ability to send warp messages. So a warp message is sent from a blockchain and an address on that blockchain. So that could be something like a staking contract. So, you could launch your own L1 and specify, hey, there's a staking contract on the L1, and essentially that contract will emit warp messages to the P chain that specifies add this validator, set this validator's weight to something, remove this validator, do things like that. Technically, that staking contract does not need to live on the L1 that it is managing. So you can use the C chain as your kind of like source of staking information. So you could have an L1 whose validator set is actually determined by warp messages sent from a contract on the C chain, or another layer 1, or anything like that. Did that answer your question? Yeah. Cool. Yeah, go ahead.
Follow up on that, like, are you able to do, for example, continuous staking because you have all the logic to manage it, so that you can just know without fixed time locks that you can just stake?
Yeah, so that's actually a very good question. So previously with BAMF, I should have included this. The transactions also, because they're following the same staking curve as the Avalanche primary network, that include specifying an end time for validators. That does not exist at all with layer 1s in Etna. So the contract will basically say, hey, add this validator, here's the weight, and they will be a validator at that weight indefinitely. There is the continuous fee that is charged to that validator. If the validator's balance becomes empty, they are basically deactivated. So really what we're charging for here is not like a state rent mechanism. We're actually trying to basically restrict the amount of memory pressure that the node can have, because these active validators are used for warp verification and also like P2P network operations. And so for efficiency reasons, we want to keep them in memory, which means we kind of need to restrict that more. But yeah, so yeah, you do not need to specify an end time for Etna L1 validators. Yeah. Cool. Any other questions? So depending on if anyone breaks the DevNet, we had originally hoped for it to be on testnet for this conference. So we didn't quite hit that, but we are currently pretty close. So I'm allergic to timelines, but that's kind of the TLDR. I don't know if that fully answers your question. I mean, it's close, right? Like the all of this is again fully implemented. So yeah, we definitely want to get on testnet as soon as possible. So certainly I want testnet before the end of the year. And then depending on when that is, I think that there will be a probably considerable time. Typically, there's around a few week period where kind of Fuji would run before we would consider like activating on mainnet. I think that this is a pretty large upgrade, so we might actually extend that a little bit longer than normal. But basically, once it's active on Fuji, it's the clock is ticking for mainnet, I would say. So unless there's some major issue, which would suck. Again, that's why we test the DevNet. So again, active bug bounty of a small amount of a box if you can break the DevNet. Any other questions? I think I'm running out of time rapidly. So, go ahead.
You touched upon like 5 ACPs, some of which have network level changes and others which don't. Can you talk about the different types of ACPs there and where people can create them and suggest them if they have ideas?
Yes. So let me pull up the original thing. So ACP 77, ACP 103, 125, and 151 all require a coordinated network upgrade. What that means is basically if some node decided, hey, I'm going to try to reduce the minimum base fee just right now, things will not work as expected. You'll have various errors, invalid Merkle root, yada, yada, yada. ACP 118 is not like a required network upgrade. It is a kind of standards track thing. So even though ACP 118 is not required for L1s to adopt, it will significantly reduce the barriers to or reduce the friction for relaying warp messages. So the ACP repo is very much designed for various things like standards, protocol level changes, things like that. So there is a repo called I think it's Avalanche Foundation / ACPs. I should have included a link, but for any protocol level changes, that's kind of where things start, and anyone can make a PR to that repo. So if there's any kind of things that people have kind of ruminating in their minds, thinking like, I really wish that like the Avalanche network would do this. Like, I don't know why they aren't. Like, totally possible that no one's thought of it other than you. So please either put up a PR to that repo or open a discussion on that repo. Also, feel free to like open the discussion on Discord or things like that. But yeah, that's a bit of an explanation behind the ACPs. Also, the numbering is just like the PR number. So 77 is a cool number, though. Do you have a question? Or?
I guess I did have one. So from some videos I was watching, I understood that you could have the validator subset be attributed to other L1s. Does that imply that you can have like multiple L1s all point to the same sort of staking contract? So any validators who go through that can validate any of the subnets?
That is a very interesting question. You certainly can have the same staking contract manage the validator sets. The warp messages do include subnet IDs or L1 IDs. So you would have to evict multiple warp messages for those operations to be performed. You can have multiple blockchains on a layer 1. So if you wanted to have like the exact same validator set, it would probably make more sense to have just one L1 with multiple blockchains inside of it. But yeah, that's an interesting question. There's been numerous conversations about whether or not that's more complex than it should be and whether or not there should just be one chain per kind of validator set grouping, but currently that is totally supported. Yeah. I think I'm very much running out of time now. Are there any last second questions? Cool. Thanks everyone for coming.